So this is AQA, higher. Where is it? Let's get the date. So it's AQA, higher, and hasn't got the date on it. Well, you can just about make it out there. It was June 21. June 21. Okay, so this is the most recent one I can find. Okay, so it's non-calculator, and we've got 1 hour 30 minutes. Okay, and carry on then. Right, so here we go. Simplify a to the power 5 cubed. Well, this is actually a to the 5 times 3, which is a to the power 15. You can think of it as a times 5 times 5. A to the power 5 times a to the power 5 times a to the power 5. And then you add the powers to make 15. Either way you do it, it's like that. If it's brackets, you multiply across the bracket. If you expand it this way, you add the powers. So in the brackets, you multiply. When you've expanded, you add, but both ways you get 15. X is not equals to 0.4. Circle the possible value of x. Well, 4 divided by 10 is 0.4. This is 2/5, which is 0.4. This one here, I already know that's the answer. I'm just going to explain why this one isn't. This is 120 divided by 300. Actually, that's not really going to be very... I'll do it anyway. It's not the best example to do this type of long division, but it'll be okay. So basically, if you need to work it, I can see that that is 0.4 because it's 4 divided by 10, and this is 2/5, which is 0.4 as well. Okay, so if you weren't sure about 120 over 300, you can say, right, 300 into 120 doesn't go, so it's 0 point something, and then you carry out the 120, and then 300 into 1,200 is 4. With no more remainders, so it's 0.4. So 26 out of 70 is 0.4. Right. Circle the solid that has 7 vertices. Okie doke. Well, I can see already that it's not these. I can see that it's this one. A hexagonal base pyramid. So a hexagon has got 6 sides. And a pyramid means that they all come to a point like so. That's a pyramid. So the vertices are the numbers of corners. So you've got 1 on the top and then 6 on the bottom. So that one's got 6. A pentagon, that one's got 7. 6 on the bottom. That one's got 7. See, this one is 5 because it's a pentagon base, and a pentagon's got 5. 5 plus 1 is 6. A hexagonal prism. Well, that is a prism. It's the same shape all the way through. And it's hexagonal, so it's got hexagons. 2, 3, 4, 5. Hexagons at each end. Okay, a bit hard to draw. Let's sing it in. Have I done that right? 1, 2. I think I have. So actually, if you count up the vertices, you've got 6 on this end. 2, 3, 2, 3, 4, 5, 6. 2, 3, 4, and 6 on that end. So that one's got 12. And pentagonal prism, that's got a pentagon on each end, so that's going to have 10. So our answer is the hexagon base prism. Here's a sketch of a graph. Circle the equation of the graph. K is a constant. Right, y equals kx. That's going to be a straight line. Y is a multiple of x. So you've got things like, if x is 0, 1, 2, 3, it's going to be 0 times, suppose e.g. y is 2x. 0 is going to be 0, 1 is 2, 2 is 4. X is 3, y would be 6. That's a straight line. Y equals k plus x. That's a straight line. Don't need to worry about that example actually. If you remember, like y equals mx plus c is a straight line, the general equation of a straight line. So this one, you've got an mx, c is 0, but it's still a straight line. This one is 1x and c is k, that's a straight line. This is also a straight line because the m is minus 1 and the c is k. Okay, so that's a y equals mx plus c. And this is the one that's curved, k divided by x. Okay, write 200 as a product of prime factors. 200 is 2 times 100. 2 is a prime number. 100 is 2 times 50. There's more ways than one of doing this. 50, 2 times 25. And 25 is 5 times 5. Okay, so we've got 1, 2, 3, 2 cubed times 5 squared. Number 6, Lily's age is 2 years and 4 months. Hugo's age is 1 year and 8 months. Write Lily's age in months as a fraction of Hugo's ages in months. Give you a fraction in its simplest form. Right, so Lily's age in months, 2 times 12 plus 4, 24, 28. 1 year and 8 months, 1 times 12 plus 8, which is 20. Lily's age as a fraction of Hugo's age. Right, so it's 28 out of 20. And we cancel it down, top and bottom divide by 4, so it's 7/5. Okay. It's over 7/5, which is 1 2/5. So Lily is 1 2/5, 1.4 again, 1.4 times Hugo. Oh, what a funny question, 25, I don't know why. I think that's funny, I just do. Right, use approximations to estimate this answer. Right, so what you do is you round them all off to one significant figure. So 97 is 100 to one significant figure. 2.014 is 2 to one significant figure. And 0.49 is 0.5 to one significant figure. So put it all together, it's the square root, so the approximation is approximately equals to the square root of 100 plus 2 cubed divided by 0.5, and that is actually equals to 10 plus 8 divided by 0.5. That is actually 18 divided by a half, which is 36. If you divide by a half, how many halves in whole 1? 2. How many halves in 18 whole 1s? 36. And number 8, 5x plus 6 is greater than 3x plus 15. So the first thing I'm going to do is take 3x from each side. So I've got 2x plus 6 is greater than 15. Then I'm going to subtract 6 from each side. So 2x is greater than 9. So x is greater than 4.5. So the next thing I'm going to do there is divide by 2. Okay. So here, write down the inequality represented by this number line. So these are x's, and x is a line between 2 and 5. Okay, and because it's coloured in, the x can be equals to 2. Because it's open at 5, it means it can get close as it likes to 5, but it can't be 5. So we actually say 2 is less than or equals to x, which is less than 5. Number 9, diagram shows an octagon, 8-sided shape. 1, 2, 3, 4, 5, 6, 7, 8. X is 1, it's here. So look, this is the x-axis in grey, this is the y-axis we've got x is 1 there, and y is 5 is across there, and their lines of symmetry. So that means that that's going to be halfway up. The y is 5 is going to be halfway up that way. X is 1 is going to be halfway between those two. Work out the coordinates of point Q. Okay, oh, yeah, they're giving us another clue there. We needed another point. P is -2, -6. Okay, and that is x is 1. So what we need to do is just fill in some gaps. If that was 1, there to there, this is x is -2, y is -6. So as we go from there to there, we go up 3. We go from -2 to 1. So that's going to be 3. And because it's symmetry, that's going to be 3. That jump will be 3. And that jump will be 3. Okay, so that means that x there, that's going to be actually 4. Because it's 1 plus 3 makes 4. So, and that's by the symmetry this way. It means the x coordinate there is 4 as well. So now we've got to do the same with the x. So this is -6. So up to there, that's y is 5. So that's 5 and that's -6. That total line is 11. Up to there. Okay, so that means that line up to there, that's going to be 11 by the symmetry. That's 11 as well. So from here, because the coordinates, we're going to go from the x line, it's actually 5. And that was 6 there. We've got 5 there and 6. That's where that 11 comes from. So it's actually 4 across, 16 up. Work out the coordinates for 16. Number 10. Work out 2,000 times 70,000. Well, the way that I would do this, I would do 2 times 7 is 14. And then we've got 1, 2, 3, 4, 5, 6, 7 zeros to go in there. Okay, and it's going to be 1.4. Right, standard form, it's a number between 1 and 10, which in my case is 1.4. Okay, and then the power of 10 that we need, well, 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the power 8. Okay. So 1.8 times, work out 1.8 times 10 squared, divided by 3 times 10 to the -1. Give your answer as an ordinary number. I'm just going to freeze this screen, hopefully. There it is. Okie doke. So on the top, well, first of all, I'm going to multiply top and bottom by 10 to the power +1 to cancel this out. Okay, so it's 1.8 times 10 cubed divided by 3. So it's multiplied top and bottom by 10 to the power -1, to the +1, sorry. So that becomes just 3. So then this is 1.8 times 10 cubed. That's going to be 1,800. Because it's, well, 1.8, got the point there, 1, 2, 3. Divided by 3, which is 600. A, B, C, D are junctions on a motorway. C to D is 3 times distance A to B. B to C, so that if that is X, that's 3X. B to C is 25 miles. Salma drives from A to C. She drives for 30 minutes at an average of 62 miles per hour. Work out the distance of A to D. Right, so let's start with this one. Well, I've put those ones there on the diagram, all that information. C to D is 3 times distance A to B. So call that one X, that's 3X. B to C, 25 miles. A to C, 30 minutes at an average speed of 62 miles per hour. So the A to C, so if she if it had been a full hour at 62 miles per hour, she'd have done 62 miles. She's driven for half an hour. 30 minutes is half an hour, so it's 31 miles. Okay, 30 minutes. Does that make sense? I'm going to repeat the same thing again. A to C, 0.5 times 62 is 31 miles. The units, it's 0.5 hours times 62 miles per hour. You see the units cancel out, so it's a half of an hour. Half an hour at 62 miles. Half of 62, 31. Okay, so A to C is actually 25. We know A to C is 31. It's also 25 plus X. So that's 31. So our X is 6. So A to D, so an X is 6, because it's got to be 6 plus 25 to make the 31. A to D is X plus 25 plus 3X. So it's 6 plus 25 plus 18, because X is 6. So it's 31, 41, 49. 49 miles. Here is a right angled triangle. Use trigonometry to work out the value of X. So we've got that the angle is 30. We've got opposite the angle is X. So that is opposite there. And this is the hypotenuse, because the hypotenuse is opposite the right angle. And the hypotenuse is 10 centimetres. So when you've got O and H, if you remember, we've got SO, Ka, Toa, O and H. This is the one that we use here. And what we've actually got, we want the opposite. We want the opposite. So it's sine of 30 degrees times H times 10. So X opposite is sine of 30 degrees times the hypotenuse, which is 10. So X. Now sine 30, that's one that you need to memorise. That's a half. Times 10. So it's going to be 5 centimetres. Right, convert 5 divided by 6 to recurring decimal. So what we do then, 6 into 5.0000. Okay, we might put more notes in if we need it, but I know that we won't, but just put a few in. 6 into 5, 0 remainder 5. Then we've got 6's into 50, got 8 remainder 2. And then we've got 6's into 20, which is 3 remainder 2. 6 8s are 48, so that's why it's 50 remainder 2. 6 3s are 18, so that's why it's 3 remainder 2. And look, we're now stuck in a loop of okay, remainder 2, so it's going to be 0.83 recurring. Okay, simplify this. Well, this one, that's wrong, because that is 3 times 4 over x times x, and we need to, it's just not right. This is wrong because it's 3 times 4 over x. That's what we want here. This is wrong because this is 3 plus 4 over x plus x. And this one is right, because if you've got 3 x's plus 3 x's plus 4 x's, it's 7 x's. You add the tops, but you don't add the denominators. You just need the denominators to be the same, and as long as it's the same, it's that same answer when you add or subtract. Okay, here, work out 2 possible values of b. Okay, well, I'm going to expand the left hand side. We've got x plus a times x plus 3a. So it's x squared, 3a, 3ax, ax, and 3a squared. So what I've done there, x times x, x squared, x times 3a, 3ax, a times x is ax, and a times 3a is 3a squared. So when we combine them together like this, they combine together and it's x squared. These combine together because these are both the x's. These are the x squareds, there's only one of them. That's just a's and constants, that's all a constant. These two with the x's in. You can combine them together. So it's x squared plus 4ax. Because what we've got here, we've got 3a of these x's plus another a, we've got 4a. And then plus 3a squared. Okay, work out the two possible values of b. So this is the left-hand side here. And this is equals to the right-hand side. X squared plus bx plus 75. Okay, so this is the clue here. Once we can get, because we've got x squared is x squared, they match up. That's the right-hand side there. 4a is equals to b. We need to work out the b, so we need to work out the a, and then we can work out the b. We can work out the a from here. 3a squared is 75. 3a squared is 75. So therefore a squared, divide both sides by 3, is 25. So a is 5, or a is minus 5. Okay, so we'll go to this one now. So we've used that one, move on to the next one. We'll say b is 4a. So b is 4 times 5, which is 20. b is 4 times minus 5, which is minus 20. Okay. Sip of coffee. The cumulative frequency graph represents the masses of 40 necklaces. So they weigh between 0 and 30, and there's 40 of them. A jeweller buys every necklace with a mass greater than 21 grams. How many does she buy? So if we go on to here, look, 21 is there. Because 20, 1, 2, 3, 4, 5. Okay, read off. I need to zoom in a little bit. I think the mass 21 comes in at 16. So she'll actually buy all these ones. She won't buy these first 16. Sorry, number 15. Well, it's greater than 21. Number 15 is less. If you look carefully, look there, it is less than. So she's going to buy these ones here. Actually, when you zoom in closely, you can see it is exactly 16 there. So she's not going to buy the smallest 15. So it's going to be 40. Take away 15. So she's going to buy 25 necklaces. Okay. The lowest mass was 3 and the highest mass was 28. So the lowest mass is 3, which is there. Highest mass 25, 26, 27, 28. Okay, and what we've got to do when it's a box plot, you've got to put a box around the middle 50%. Okay, so I'll just rub some of these out. So what we've got to do is we've got to look for the lower quartile, which is 10, and that has a mass, that's 18, that's the lower quartile, and it's because there's 40 up there, so the lower quartile is 10. The upper quartile is 3/4 of the way up, so that's going to be 30. that's 24. I'm going to read off the 30. So I need a box around 18 and 24. 15, 18, 24. I don't know if I said that right. The bottom is the masses, and this is the numbers at the side. So it's between 18 and 24 grams. So we draw a box around them. Basically, so in there, because that's the middle 50%, lie between 18 and 24. But then the extreme values are here, like 3 and 28. So we just include those, the very lowest that way and the very highest that way. Okay. Okay, next one. Circle the vector that translates the point -2, 7 to 3, -1. So if -2, we've got -2, 7, and it moves on to 3, -1. So the first coordinate goes from -2 to 3, so that's +5 in that one. And the second one goes from 7 to -1, so it's got to be -8. So it's +5, -8. Okay, so it's like, this is the starting point. You've got to add 5 to the first coordinate, that brings us up to 3. Then you do 7 minus 8 is -1. So that one works. Here's a triangle. Give a reason why the side AB cannot be 35. Well, you think about this as walking direct routes from A to B. If you go via C, it's automatically going to be longer than going directly to B. Okay, because if you go via C, you do 17 plus 13, which is 30 metres. So the direct route can't possibly be more than 30 metres. Okay, right, A to C plus C to B is 17 plus 13, which is 30 metres. Okay. A to B is the direct route from A to B. Now, if A to B, if A, that says it looks a bit weird then, wait a minute. A to B is the direct route from A to B. If we go, if we go from A to B via C, if going from A to B takes 30 metres, is 30 metres, the direct route must be less than 30 metres. 1 mark, I think I've earned it. Here's a different triangle. 31, 54, 72 degrees, x degrees. Leah tries to use the sine rule to work out the size of angle x. Here's the first 2 lines of her working. So she's got x over sine 31 is 54 over sine 32. X is 54. So what she's done, she's sine, this function has to be applied to an angle, and she's applied it to the length of the side. So what errors she made? She needs to start with, so it's actually, I would start with sine x over 31, and then I would actually do sine 72 over 54. If she wants to start with the angle on the top, which is useful for working out things, you do sine of x over 31, and put this with the sine on top as well. So the other side would be sine of 72 over 54. She can start that way, or if she wants, or, because you can reverse them all, so you can say it's 31 over sine x equals 54 over sine 72. You need to take sine of an angle, not of a side. 1 mark, so there we go. Number 19, we've got questions here. How many questions? I always start wondering how many questions. But we've got lots to go, lots and lots. Lots and lots and lots. 28, 29, 29 questions. Which one am I up to? This one, number 19, out of 29, 10 to go. 2/3 of the way through, yeah, roughly. Right, items made at a factory have to pass 2 checks. 90% pass the first check. The items that fail are scrapped. 99% of the items that pass the first check pass the second check. The items that fail are scrapped. Complete the diagram. Right, so first check, 90%. I'd write that as a decimal, or I wouldn't write it as 9/10. I wouldn't write it as 90%. And even I'd write the right answer. Look, I'm not looking on. They've got the pass there as 0.9, so that one is 0.1. Okay, so the next one, that's going to be 0.99, that pass, 0.01. Okay. An item is chosen at random before the checks. Work out the probability that the item is scrapped. Okay, so now you can't do it as 0.1 plus 0.01. Okay, what I would do for this one, I would do it as 1 minus the probability that it passes. Okay. Is because see that 0.1 comes from this 0.9, and then this one here is not going to be 0.11. So we work out the probability that it passes, and we'll do 1 take away that. So it's 1 minus, and the probability of a pass is 9/10 times 99 out of 100. So I've got to do 9 times 99 now. Right. 9 nines are 81. 9 nines are 81. Plus 8 is 89. So it's 1 minus 891 out of 1,000. Because 10 times 100 is 1,000. It's out of 1,000. And I'm pausing because I'm checking as I'm talking and thinking. Yeah. So it's 109 there. Okay. Thinking 0.109. So it's not just 0.1 plus 0.01. Just slightly different. It's all to do with what you might think. So to go down that branch is 0.1. To go down that branch, 0.1 people go down that first branch. This one is 0.9 times 0.01 go down that branch, which is 0.09. Now just leave it like that. put it back. Oh dear, it's first thing in the morning. I've got my numbers wrong there. It's 0.9 times 0.01, 0.009, okay? So that's a fail, and that's a fail. You can either do it as one, take away that, or you add these two together, you see, and then 0.1 plus 0.009 is 0.109. Okay, so there's two ways of getting to it, but this, yeah, whichever one you like the best. You either add up all the fail branches, but just remember to multiply this first of all. And this one doesn't need to fail. That's why it might put you off. But anyway, there we go. Which one of these is not a unit of density? Circle your answer. Density is mass divided by volume. Oh, which of these is a unit of density? I was going to say. Right, so it's got to be a mass, so we need like either grams, kilograms. Oh, it's grams in this question. This question is all about grams and centimetres squared or cubed. So it's grams and volume, centimetres cubed. So the one that is, and it's grams per centimetres cubed. That one, that's grams per area. That one's volumes per gram. And that one's area per gram. Grams per centimetre cubed is that one. So, yeah. 21. First two terms of a quadratic sequence are 10 and 17. Okay, here's some information. Work out an expression for the nth term of the sequence. Okay, so when you've got a quadratic is an squared plus bn plus c. So that's the nth term, tn term, just put t if you want there, is an squared plus bn plus c. Now a is a half the second difference. So a is a half of 6, which is 3. It's 4 marks, so we do need a bit of. So we've got, so the nth term is 3n squared plus bn plus c. Okay, so if it's a quadratic, yeah, the coefficient of the n squared is half the second difference. So what I'm going to do now, let's fill in some more gaps of these. Fill in these gaps. That's plus 6, so that's 19. Here, this was plus 13, so that's 30. And then it's 59. So we go up by 7, then by 30, and then 49 even. Just checking I've got these right. 13 plus 6 is 19, 10 plus 7, 17 plus 30, 31. Okay, so we know 3n squared is part of it because of this. Okay, so now I'm going to take the sequence 10, 17. So our ends are 1, 2, 3, 4. Our sequence is 10, 17, 30 and 49. And what I'm going to do is take away 3n squared. So I'm going to take away 3 times 1 squared for that one. I know it's in it. I fixed it in it. So now I'm going to take it away and see what's left and work out the sequence of what's left. So 3 times 2 squared is 12. So I'm going to take away 12. So that's 7. That's 5. This one, 3 times 3 squared is 27. So minus 27, which is 3. And this last one is 4. Minus 3 times 4 squared, so it's minus 3 times 16, which is minus 48. And that's 1. And I'm happy because I've got a pattern. So this sequence here is going down in 2s. So if it goes down in 2s and it's a first difference, so basically we started off with this one here, but we've made it now into this one by taking out the 3n squared, which was, you can see straight away there. Okay. Now, if the first difference is constant, that's what we're looking for. We've got a constant second difference, so you half it and it's 3n squared. We've got a constant first difference, so it's minus 2n. Okay, so that's part of the sequence. We've got 3n squared minus 2n, and that's because it's going down in twos. Now the first one is 7. What we do is, this means that the b just trying to keep this neat. 3n squared, isn't it? A is 3. Yeah. B is minus 2. Okay. And that's because the first difference here is going down in twos. To work out the constant, the c, what we do is we take this sequence, this one here, and we go back, and it's 9. Okay, so c is actually 7 plus 2, which is 9. Okay, so what happens here, this sequence is going to be minus 2n plus c, because we've taken out the n squared, minus 2n plus c. So minus 2 times 1 is minus 2, we've got to add 9. Minus 2 times 2 is minus 4, we need to add 9 to make this make the 5. But what you can think is that when you've got n is 0, it's going to be minus 2 times 0 is 0, so it's going to be plus 9. So by working backwards, you can work out what the plus c is. Oh, there's a lot in that one. To explain it while you're doing an exam is quite a lot. I guess, yeah. C is 9. Right, so the answer is 3n squared minus 2n plus 9. So the nth term, we don't really need to put that tn in, because that's a bit confusing. Anyway, write out the value, work out the value of 5 over 7 to the minus 2. So what you can say, the negative means take the reciprocal, the negative part. So I've dealt with that by taking the reciprocal, turn the fraction upside down. This is 49 over 25. So when you square, it's going to be 7 times 7 on the top, 5 times 5 on the bottom. Right, rearrange to make y equals 1 over the square root of x plus 1, the subject. So we start with, we can say x. 2 ways of doing this, so I'm going to do it 2 ways. If we start with x, then we add 1, and then we take the square root, and then we take the reciprocal, and out comes y. Okay, we'll go backwards. Right, the reciprocal has got its own, we're going backwards, reciprocal stays the same when we go backwards. Square root is square, add 1, we do the opposite functions on the bottom, out comes x. So what we can say is, to make x the subject, x is, we start with y, we take the reciprocal, then we square it, then we take away 1. Because you go through here, y, take the reciprocal, then you square it, then you take away 1, and out comes x. That's one way of doing it. Or we've got y equals 1 over the square root of x plus 1. So multiply both sides by square root of x plus 1. Y times the square root of x plus 1 is 1. Then I'm going to divide by y. The square root of x plus 1 is 1 over y. And then I'm going to square each side. So x plus 1 is 1 over y squared. And then I'm going to subtract 1 from each side. So x is 1 over y squared minus 1. Okay, so 2 ways you get the same answer. Number 24. Is there some big questions coming up? Yes. I know we get to question 29. Not really? Okay. Oh, 28. Oh, right, just keep going. Right, f of x is cx plus d, f of 4 is 7, f of 10 is 22. Work out the values of f and c. Right, so cx, right, when x is 4, let's start with x is 4, don't need to write that out. This here, this means, look, when x is 4, so what we've got here is x is 4 over here. So we've got 4c plus d is 7. That's that one there. If we substitute x in here, so we get c times 4, which I've written as 4c, plus d equals 7. We'll do the same with the 10. We've got 10c plus d is 22. Call that equation 1, that equation 2. I'm going to do equation 2, take away equation 1. We get 6c is 15. So I did 2 take away 1 to cancel out the d's. 10c take away 4c is 6c. D's cancel. 22 take away 7 is 15. So this means that c is 2.5. Okay. Substitute for c in 1. 4 times 2.5 plus d is 7. So 10 plus d is 7. So d is minus 3. And then you can check it with the last one. I'll write the check down. Probably in an exam I'd do this in my head, but I'll write it out now anyway. So we'll check with number 2. 10 times c plus d is 10 times 2.5 plus minus 3. And that does equals 22. So I'm happy. C is 25, D is minus 3. Okay, next one. 24b. Oh, that's why there's so many pages, because it's A, B, C's. Right, 24b. G of x is 2x. H of x is x minus 1 over 2. Circle the expression for hg of x. So this means apply h to g of x. So we've got to do, the way this is worded here, we've got to do g of x first of all, and then we've got to do h to it. So this is h to g of x is 2x. So we've got to do h to 2x. And when we do h to something, we do the something, take away 1 over 2. But our something is now 2x. So we've got to do 2x minus 1 over 2. That one there. It's applying it, so 2x minus 1 over 2. So basically, we've got to put g of x in there, because it's h of g of x. Right, show that the square root of 150 minus 6 over root 2 times root 3 simplifies to an integer. So the square of 150 we need is actually 25 times 6. Square root of 25 times 6. I'm looking for a square number that goes into 150 and 25. And it's 5 root 6. Now, I was pleased when it was root 6, because I've got a root 6 going on there, and I've got root 6's going on there as well. So I know I'm on the right track. So instead of 150, one more thing, root 2 times root 3 is root 2 times 3, which is root 6. So this actually becomes 5 root 6 minus 1 root 6 divided by root 6. So it's actually 4 root 6 on the top divided by root 6, which is 4. And the integers are whole numbers, positive or negative or 0. 4 is an integer. Basically, we've cancelled out all root 6. We've removed the surds. 26. D is 2f. E minus f over d minus e is 1/4. Work out the ratio e to f. Okay, well, I want e's to f's. I've got lots of e's and f's in here. I definitely don't want d, so I'm going to replace this d here by 2f. So e minus f over, what's that? 2f, because it's a d, and a d is a 2f, minus e is 1/4. Okay, so what I'm going to do now is multiply both sides by 2f minus e. So e minus f is 1/4 2f minus e. Multiply both sides by that. So if I multiply this side by 2f minus e, it cancels out here, and it becomes in the numerator up here. I'm also going to multiply by 4, both sides by 4 to cancel out the quarter. So I've got 4 e minus f is 2f minus e. I don't actually need those brackets anymore. So I'm going to expand. 4e minus 4f is 2f minus e. I'm going to add e to each side. 5e minus 4f is 2f. And then I'm going to add 4f to each side. 5e is 6f. So if 5 e's are 6 f's, when you actually do e to f, it's actually 6 to 5. That's not a mistake. If we think of a number, say like 60 jumps to mind. If we've got 60, if 5e equals 6f is equals to 60, this is only an example, it's nothing to do with the question. 5 times 12 is 60, so e is 12. And the other one is 6f. 6 times 10 is 60, so f is 10. So the e has got to be bigger than the f. And it's because you multiply e by this smaller number, and it's the same as f multiplied by with a larger multiplier there. So f has to be smaller, because more of them has to make the same as 5 times the e. So there's an opposite thing that goes on. Now you don't need that example as part of, that was just to show you what's going on. So if you end up like this, and it's got to be in a ratio, you swap the numbers. Okay, number 27, hey, we're getting there. The vertices, sorry, my throat's a bit funny. Let's do this in the morning when it's quiet. But I also like lots of cups of coffee in the morning. Anyway, let's carry on. Vertices of a regular hexagon, so it's 6 sides, all with the same length sides and angles. Right, so there's a lot going on here. Because it's a hexagon, you've got 360 degrees around this circle. And because it's a hexagon, it's split into 6. So actually, all these angles, if we actually draw in all these other angles here and shared out this, they'd all be 60 degrees. Now 60 degrees, and because these are the same, these are 5 and 5, we've actually got lots of equilateral triangles here. So that's a 60, that's a 60, and that's actually 5 centimetres as well. Okay, so I'm going to take some of these drawings out. I can't take that one out, it wants me to keep that one in. Okay, so I've actually got equilateral triangle there. Work out the shaded area. Give your answer in this form here, where A, B and C are integers. Right, so it's 4 marks. Right, so the area of a circle, feels like it should be more, is pi r squared. Well, our r is 5, so it's 25 pi. Okay, that's the full circle. We've got, I'll come on to the fact that it's a 6th later. Right, the area of the equilateral triangle Okay, so we've got two sides and an included angle. So it's a half of the two sides multiplied together, which is 5 times 5, a half AB, and then it's sine of the angle between them. Half AB sine C is the area of a triangle, if it's not a right angle triangle, when it's a half base times height, which it is, anyway, that's where they teach it at GCSE. So the area of the equilateral triangle is a half of the two sides and multiplied together, also multiplied by the sine of the angle between them, 60 degrees. So this is 25 over 2, and sine 60 is root 3 over 2. So that's another one that no, it's not. Yes, it is. Sine, we had sine before in the other one, we had sine 30 was 1/2. Sine 60 is root 3 over 2. Need to memorise these. Okay. If you've got sine 60 degrees, sorry, cos 30 degrees is what I've already done, sine 60 there. Cos 60 degrees is a half. See, it switches round, and sine of cos 30 degrees is root 3 over 2. So they switch round. Sine 30 is a half, cos 60 is a half. Sine 60 is root 3 over 2. Cos 30 is root 3 over 2. Need to memorise them. Yeah. Okay. Go back to this one. So sine 60 is root... I've already done that one. Sine 60 is root 3 over 2. Okay. So I'm just thinking whether to go for the... Well, if we do the full circle... Oh, right, so if the area of the equilateral triangle is this, the area of the hexagon is going to be 6, because we've got 6 of these triangles. Okay, and then the 2's there, cancel that one to be 3. So it's 3 times 25, which is 75. Root 3. Okay, just going to check numbers. So it's, we've got 6 of these. This is a triangle. We've got 6 of them because it's a hexagon. 6 times all that. No. Yeah, I'm glad that I stopped myself there. Right, so it's actually, that's actually, so it's, 6 times 25 is 150 root 3 divided by 4. So it's cancels down to 75 over 2. 75 root 3 over 2. That's the full hexagon. Right, so the shaded area is the circle. Take away the hexagon, divided by 6. So it's 25 pi minus 75 root 3 over 2, all divided by 6. And if I multiply, so what I've got here, circle, 25 pi, minus the hexagon, 75 root 3 over 2, and divided by 6, because that bit there is just one, the 6 of these, and divide that by 6. Okay, I'm going to multiply top and bottom by 2 now. So it's 50 pi minus 75 root 3, all divided by 12. Okay, multiply top by 2 and bottom by 2. Okay. Right, number 28, here's the graph of y equals cos x. It is indeed, in parts A and B, the graph of y equals cos x is shown as a dotted line. So that's here. So they're saying draw the graph of y equals cos of x minus 90. Okay, so what you do is if it's minus 90 inside this bracket here, this is cos of x as it is. You actually move it on to plus 90. You move the cos graph 190 that way. So that one's there, that one's there, that one's there, and that one's there. Okay, because now if you do 90, when x is 90, you take away 90, so it's 0. So it's cos of 0, or cos of 0 is 1. That's why it starts there. So that's why it moves on. So shift that way. Draw the graph of 1 plus cos x. So when it's outside like this, it's plus 1 that way. So it's there, 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 there. Okay, there's always plus 1. So you do the original cos and then add 1. Rita tries to draw the graph of cos of minus x. Here is their graph. Give a reason why she is incorrect. Right, she has drawn y equals minus cos of x, not so basically there is a difference. Cos of minus x, well, you see the cosine graph looks like this, as you know already, and it continues this way. So cos of minus x, you know, that's cos of 90. Cos of minus 90 is the same as cos of 90. Cos of minus 270 is the same as cos of 70. So what you actually have is that cos of minus x is the same as cos of x. Okay, sine of minus x is minus sine of x. That would be a teaching point rather than it's not part of this exam, because the sine graph looks like this. So the sine of the negative number is minus the sine of the positive, because it's got this rotational symmetry. So I think that's what she's mixed up. Yeah, it would work for sine, not for cosine now. Right, here's a triangle ABC on a grid. Describe a single transformation of the triangle so that B is invariant, so that stays where it is. A moves to 1, 1, 1 across, 1 up, and C moves to 1 across, minus 1. So that's the new A, that's the new C. Goes down there, down there, down there. Okay, so can you see, to get from there onto there, giving a clue with my arrow, it's a rotation. It's 180 degrees. It doesn't matter if it's 180, whether it's clockwise or anti-clockwise. And the centre is B, which is minus 1 across, 1 up, point B. There we are.